Okay, good morning everyone. So yesterday we were doing the drawing of the electronic structure, or sometimes known as the dot and cross diagram, okay, of atom, which is the most simplest case, because later on we are going to proceed to ions. Okay, that's where it gets a bit more difficult. Yeah, but for this week, okay, let's just want to get the foundations right. Okay, so remember yesterday we explored the rules when it comes to writing of the electronic configuration. So remember, the first shell maximum is 2, the second shell maximum is 8, and the third shell maximum is 8. And then for the fourth shell maximum is 2 for the first 20 elements. Alright, so we look at both the electronic structure as well as the electronic configuration. Alright, okay, both the drawing and the writing form. Okay, so this is the writing form, and then from there we realize, your period is equals to the number of shells, and for the group is equals to the number of outermost electrons. Alright. Alright, okay, then we explore. So yesterday we did this exercise. I don't know whether it's a very painful exercise for you all. Okay, so remember when we draw the dot and cross diagram, we place the electrons at the 12, 3, 6, and 9 o'clock position. Okay, the 12, 3, 6, and 9 o'clock position. Okay, so from there I think it's quite obvious that you are able to see lah. Okay, period 1 is 1 shell, period 2 is 2 shell, period 3 is 3 shells. Alright, that's the row lah. Alright, okay, and then of course the group. Alright, okay, so period group 1 is 1 outermost electrons. Okay, if you take a look at this. Alright, okay, so remember to go and complete this exercise. Alright, yeah. Alright, if you haven't. Alright, for those who missed yesterday's lesson, also please catch up. Okay, so I just left 3 examples for the benefit of those who have missed yesterday's lesson, or somehow you miss out some pointers yesterday. Alright, okay, so I'm going to draw the chlorine. Chlorine is 17, so that will be 2, 8, 7. So a little bit outside the box is actually fine. So your 2 and 8, then your 7. Okay, so you draw single first, then start pairing them. Alright, okay, so that's for your chlorine 287. Alright, okay, the rest on the fourth period, okay, this is 2881, this is 2882. Alright, so for your potassium, I'm going to draw it this way. Okay, maybe let me erase the 19 slightly. Okay, I'll put it here. Okay, so your potassium is 2. So this one you need a bit more space. Okay, 8. Then 8. So I single, then I pair. And finally the 1. Alright, okay, and lastly calcium is 282. So maybe I throw over here, not enough space. Okay, so exam I'll give enough space, definitely. Right, so this one is 282. Alright. Okay, I think I'm done with the very long exercise of the electronic structure of atoms. I hope you are done too. Alright, okay, so now let's go to the questions on the next page. Okay, so the first shell of the electrons can be occupied by 2 electrons. That's true. Okay, because for example, when you write lithium is 2, 1. This is the first shell. Yes, maximum just 2. So this part is true. Okay, so third shell of the electrons can be occupied by maximum 8 electrons. Yes, also true for your level. Okay, at O level is true. Okay, so sodium and potassium have the same number of electrons. That's not true. So sodium is 281, potassium is 2881. Alright, okay, so this one has got 11 electrons, this is 19 electrons, so that's actually the false. Alright. Okay, so sodium and potassium have the same number of outermost electron. Yes, true. Both belongs to group 1. So you have one outermost electron. Valence means outermost electron. Okay, that is correct. Okay, then your helium and neon have the same number of valence electrons. So helium is 2, neon is, okay, here I have a look, 2, 8. Alright, so that is false, although they are from the same group. Okay, group 18 is a bit special. Okay, then helium, carbon, sulfur all have 2 electrons in the first electron shell. Helium is 2, carbon is 2, 4, sulfur is 2, 8, 6. So that is correct. Yeah, all got 2 in the first shell. Okay, this is true. Okay. Alright, then we are going to look at the nucleic notation and then fill in this table in question 6. Alright, so for beryllium, okay, this is 4. The bottom is the proton number. The top is the mass number. Okay, so 4 protons, 4 electrons, because they are all atoms. Neutrons is 9 minus 4. Okay, so take the proton number, subtract from the mass number, so you get 5. Okay, mass number, another way you call it is called the nucleon number. Okay, atomic or proton number. Okay, so next one is 17 protons, 17 electrons, so that is your chlorine. 17, but don't use the one on your periodic table. That's the relative atomic mass. This is 37. Okay, it's what we know as an isotope. Later on we're going to look at it. So this is 287. This is 2, 2. Okay, next we have 13 electrons, 13 protons. So aluminium is 13, this is 27. 13 plus 40. Okay, and finally you have potassium, 19 protons, 19 electrons. This is 41 minus 19, so you get 22. So 2881. Okay. Right, then crossword puzzle that you can try out first if you haven't. Alright, okay, let's have a look at this crossword puzzle. Okay, so the element with the chemical symbol W. Okay, so this one you can go to your periodic table, check out the chemical symbol W. Okay, that is your tungsten. Proton number 74. Okay, so here you have your across tungsten, the one that you use to make the filament, about tungsten bulb. Alright, okay, I'm done with this. Okay, so the element in period 2 group 14. Sorry, this one should be 14, not 4. So group 2, period 2 group 14. You see, so this one is period 1, 2, 3, 4. So period 2 group 14 is carbon. Right, carbon. So when I tell you the period and the group is almost, you can identify the element. Alright, so that is carbon. Okay, let me go back. This is carbon. Okay, and then the element in period 4 group 13. Okay, period 4 group 13. Let's see. Period 4 group 13. Gallium. Alright, gallium. Okay, then the other one is element with a relative atomic mass of 56. So we're going to see this is the mass number on the periodic table. Okay, it has a different meaning from mass number although it's both 56. I'll explain why in the next segment. Periodic table so 56 is iron, alright, in group 8 Okay, down here you have iron, alright. Okay, so that's how you do this okay, more of an exercise to familiarize yourself with the periodic table. Okay, then the third smallest noble gas, that is, if you look at here, your argon, alright, argon so one down so argon. Then element with atomic number, that is your proton number proton number 92 okay, so you go to your periodic table. 92 is here, uranium, radioactive one. Okay, uranium. Next one, the element directly above lead in the periodic table. Okay, let's have a look where's lead lead is actually here, so that is tin directly above. Okay, so this is your tin. The element between carbon and oxygen, so have a look, carbon and oxygen, so that is your nitrogen. Alright, okay, nitrogen in this case. Nitrogen. Okay, nitrogen alright, okay, so then we are done with this page. Alright, okay, so we can now proceed to the next page on isotopes. Alright, okay, so what is isotopes isotopes are atoms of the same element, okay, with don't forget this part there's actually 3 parts to this definition. Atoms of the same element with the same number of protons but different number of neutrons. Okay, so there's 3 different parts, same number of protons, different number of neutrons, but don't forget the part they must ultimately be atoms of the same element. When your proton number is the same, you will be the same element alright, okay, so this part is linked to here. Okay, proton number is the same, it will be the same element. Okay, so isotopes have different mass number. Okay, as you can see okay, chlorine 35, chlorine 37. Okay, so their proton number of course both is 17 alright. Okay, so let's take a look at this very typical example of isotope so the proton is the same, the electrons also the same, but neutron is different okay, and then mass number of course as you can see is also different. Right, okay, then since the isotopes are different in their mass number, okay, we express them in their mass number, like chlorine 35, chlorine 37, carbon 12, carbon 14, hydrogen 1, hydrogen 2. Alright, okay, which is known as deuterium. Okay, so just take note of the definition of isotope. Okay, so isotope, since they have the same number of protons okay, they basically have the same chemical properties. Alright, they have the same chemical properties okay, same chemical properties. Okay, are considered to be the same element. Alright, same number of protons, because they as a result of that they will have the same number of electrons as well. Okay, however, since there are different number of neutrons, the isotope also have different atomic mass. Okay, so this actually results in different physical properties. Okay, such as melting, boiling, right? Okay, they have different number of neutrons, right? So different physical properties, okay, same number of electrons means same chemical properties. So chemical properties is actually determined by the outermost electron, otherwise known as the valence electrons, right? The outermost electrons. Okay, I use these two terms very interchangeably. Right, okay. Then relative atomic mass, just going to do a very touch and go. Not going to use too much at this point of time. Okay. More for a later chapter. Okay, called mole calculation. Okay. So the basically okay, if you look at the example of chlorine, okay, on the periodic table is 35.5, right? Reason is because in nature there are two isotope, chlorine 35 75%, this is 25%. Alright, so you convert to fraction and then multiply by the mass, the isotope mass, okay, this is the isotope. Okay, so this one you don't need to know. I seldom will test you this kind. This one is just more of like FYI, for your information only. Okay, not tested okay, this is not tested alright, okay, but more to that, you understand why is it a decimal. Alright, okay, so okay, so basically there are different isotopes. So the mass of one atom in the periodic table is taken as the weighted average, okay, of the various isotopes. So the mass number of a specific atom or isotope, right, okay, is the number. Okay, mass number you need to know it's the number of protons and neutrons in the nucleus, okay, of an atom. Alright, so it's simply a number, no units. Okay, but relative atomic mass, right, the definition is different. It's the average mass of one atom of the element compared to 1/12 of a carbon 12 atom. Okay, so we will explore this definition in a later chapter. Okay, over here actually I look at mass number, or what we call the nucleon number, more. Alright, okay, so now let's take a look at this part down here. So two atoms of the same element have different nucleon numbers. Okay, so which row is correct? Okay, so that means they are isotope Alright, so isotope definition is what? Same number of protons. I write short form but you can't. Okay, different number of neutrons. Alright, okay, so option A in this case. Alright, okay, then next question for isotope. Okay, so there are three isotope: protium, okay, deuterium, tritium. Okay, so the nucleon numbers are 1, 2, and 3. Okay, so of course they are all belong to hydrogen, so proton number is 1. For this one is 0, this one is 1, this one is 2 okay, 2 minus 1, 3 minus 1. Alright, okay, so melting point of the D2O, so the one that is made of deuterated water, okay, and that of H2O is 0 degrees Celsius. How come got difference in melting point? So physical properties, remember just now we were saying things like melting boiling point as well as density, okay, or things like electrical conductivity or solubility. These are the physical properties. Usually they are measurable. Chemical properties, then we are talking about the reactions, chemical reactions, right? Okay, So basically the deuterium nucleus okay is you can say is heavier, okay, than or more massive also can okay, than the protium nucleus, okay, due to the higher mass or nucleon number. Okay, so more energy, okay, this one I'll explain at a later part. More energy is required. Okay, so I'll explain at a later the next chapter on what is this intermolecular force of attraction. Okay, so more energy required to overcome the stronger intermolecular forces of attraction. Alright. Okay, between the D2O molecules as compared to the H2O molecules. Alright, okay, then I think I will stop here for today's lesson. So please fill up the relevant pages. Alright, okay, in your notes. Alright, I'll continue with the ions part for next week because that is tougher.